Hello Science 30 and welcome to the video on photochemical smog. So to get started, you're going to have an opportunity to watch this video either before this video or after. So take a moment and listen, and it will explain a little bit of the science behind smog, a little bit more in depth than what I'm going to do. So you'll learn about things like pans and different chemical reactions that are occurring. But essentially, I'm going to keep it simple in this video and just kind of talk about what is photochemical smog and then the few kind of reactions that occur with what is it. So photochemical smog is this brownish haze that hangs out in our troposphere. So a couple things that we need to talk about. What does photochemical mean and what does troposphere mean? So troposphere is actually the first layer within our atmosphere. It goes troposphere, then stratosphere, then mesosphere. And essentially troposphere is the one where you can see planes flying through. It's the lowest level. So this brownish haze, this smog, hangs over cities, and it's called photochemical because photo means sunlight and chemicals, well, chemical means chemicals. So photo coming from sun, chemical meaning there's a mixture of chemicals. So what's happening is there's a bunch of different chemicals that are being exposed to sunlight and causing reactions that ends up causing this smoggy haze that hangs out all over bigger cities. Now, photochemical smog is a little bit different than regular smog. If you've ever heard of smog, you might think more of a brownish black kind of haze, like think London back when it was first going through its revolution and all that. Smog is a mixture usually of coal. Photochemical smog is actually a mixture of nitrogens and carbons and hydrogens and oxygens. It's a lot more complex. The why we want to talk about photochemical smog is the most severe forms of environmental damage comes from air pollution. You also can look it up, and I'm pretty sure that it's around 7 million people worldwide die or are like they are very sick from air pollution. That's not just smog, it's a variety of things. So that's why we want to talk about how does this affect our health. So if you look here, this is another example of photochemical smog. So you can see it's blanketing the city. Interesting enough, smog covered London. I think it was like 1952, and it shut down all of London. This big, heavy smog rolled in, photochemical smog kind of rolled in and covered London, and things shut down. Trains, railway stations, roadways, and all that stuff. People got sick and had to go home. You couldn't do anything because it shut down. And it essentially lasted for a little while and then it disappeared. So interesting. But photochemical smog that we're going to be talking about, thinking like LA or anything like that, is caused by automobile emissions of nitrogen oxides. Now, one of the most interesting things I think of when I think of photochemical smog is I think of the drastic comparison of what has happened during the pandemic. You can look up pictures of LA then and now, India then and now, China then and now, when cities were in lockdown and nobody was driving really on the streets, nobody was running factories, nobody was really working. As terrible as that was, we saw a huge change in what our air quality looked like. Most people breathe in and out air that is actually really dangerous for them every day. And that's why you see a lot of people in larger cities like in Beijing or in Tokyo that wear masks all the time pre-pandemic. And that's because they were worried about the irritants that get into their lungs. Because when you have smog, that can cause massive issues on respiratory ailments. It can cause asthma, COPD. It can make you really, really sick. It's really bad for the elderly. It's really bad for the really little. So that's why you don't really want this. So it's really interesting to see how the pandemic really showed us our air quality change. Another really interesting thing is in London, they have this really cool, unique statue that has made out of metal, and inside of it is a lung. And what it does is the color of the gas inside the lung changes, and it shows you and changes and measures the nitrogen oxides that are in the air. And when it gets bad, you can see that those levels are rising. So how does this occur? So the first thing we have to understand is that there is a reaction that is involving cars in the atmosphere. So prior to the 60s, 70s, I believe, most vehicles did not have what we would call scrubbers, okay, or catalytic converters. And catalytic converters are really important now in all these things part of cars because they help with emissions that come out of the vehicles they're driving. So when your car engine is running, we emit nitrogen oxides. Within the atmosphere, those nitrogen oxides combine with atmospheric oxygen to make nitrogen dioxide. So that's what we're seeing here. The car engine creates these nitrogen oxides. Within our atmosphere, we make nitrogen dioxide. Now, one thing you have to understand is that whenever you have nitrogen dioxide, sulfur dioxide, uh, or anything like that, you can, when mixing with water, can cause an acidic reaction. So that's what we're going to talk about, kind of happens and how we kind of get photochemical smog occurring. So the second reaction that happens is when we use energy from the sunlight. So first we had the nitrogen come out of the car. Then it went into the atmosphere and made nitrogen dioxide. Now this nitrogen dioxide is getting hit by sunlight and splitting that oxygen away again. So now you have nitrogen oxides and you have an oxygen, a free oxygen agent. That free oxygen agent, this guy right here, ends up finding other atmospheric nitrogen and forms something called the ozone layer. Now, we naturally have a protective ozone layer up in the stratosphere. That's the area above our troposphere up here, okay? However, when you have atmospheric ozone forming in the troposphere, that's really dangerous. It locks in pollution and heat, and it's actually extremely dangerous for us to breathe in ozone levels. So it is important that it doesn't come down lower, that it stays in that protective level. Now, while it's in this area, what happens is this little nitrogen right here forms with water and makes an acid. And so you get acidic rain coming from this. And this is how we get the building up of photochemical smog, is the breaking apart of volatile compounds, nitrogens, carbons, and all those things. And eventually it's forming pollution and heat below, trapped in by this low level ozone layer. So ultimately, that is photochemical smog. It's caused by sunlight splitting nitrogen. It's caused by oxygen forming up with other oxygens to make low levels ozone layers. And then it's trapping in heat. Now, photochemical smog, you can see it probably best in the mornings at big cities when there's not a lot of movement of air. Also, the hotter it is, the more likely you are to see photochemical smog forming, because it is obviously photo meaning light. So it's really important to understand that, like, light, and when it's really hot, you're going to get that massive covering of photochemical smog. The other interesting thing is that if you are wanting to try and avoid that, is you want to fill up your gas, like you want to fuel up earlier in the day, so you're like running your vehicle later in the day when it's cooler, or you want to walk or take bicycles or take trains or buses and do the carpooling thing. This will help reduce that kind of extra excess nitrogens that go into the air. So hopefully that makes a little bit of sense. Photochemical smog, just bad. Breathing it in, bad. Makes you sick. A lot of places are trying to put in certain types of laws and restrictions so you can't burn certain things or do certain things, because they are trying to reduce this, because it is very dangerous to our health. So if you have any questions, please let me know.